So our question and answer now will be separate recording, and everybody who, if you want to have if you have a question or if you just have a comment or general discussion, this is time for it now, but make sure you unmute yourself if you want to say something, okay? Doug, you could close your share if you want to now.
Oh, okay.
If you see how to do that.
Stop share.
Yeah.
Okay, good. Oh, good. I can see more people. Some I thought I'd lost. Open for discussion.
So I have a question right off the bat. And when you have a class of 100, I know you mentioned about clickers, but can you have discussions when there's a class of 100 of any sort? And if so, how do you go about that? Are there techniques for that?
Well, it's the groups of 3 that are doing the discussing. So imagine there's 100 students and roughly 30 groups. And what each group is supposed to do is to figure out a plan, right? And so what I do as the facilitator is as they're working on their plans, I and my undergraduate learning assistant, we walk around and, what are you thinking? We give individual groups some hints. We let that go on for maybe 15 minutes. And then we start picking on the groups and say, what is it that you want to see? And, one group will say, well, we want to see sunset here in Boulder before we go to the new place. And we want to know where and when the sun sets. And then I'll say to the class, how many groups want to see that? And pretty much it's unanimous. The nice thing about this activity is the number of observations people think of is pretty finite. There's maybe 6 or 8 things people want to see. And so pretty much everybody agrees. Then we do sunset and tell everybody the time, and they all write it down. And then another group will say, oh, we want to see midnight. So we'll let the sky keep turning in Boulder and we'll look and see midnight. And, some of them will say, oh, there's Polaris. Okay, I want to measure Polaris. And others will say, no, stupid, it's 40 degrees. And then people will mess around with Polaris for a while. And then it pretty much dies down. So what would you call that? It's directed discussion. But I think because the number of requests are pretty finite, it's proved to be pretty manageable. And, then we go to the new place and the groups get to talk. But pretty much they want to see sunset and sunrise. They want the nighttime. They want to see Polaris. Some of them try and spot constellations and remember which ones are winter and which ones are summer. It's only a minority of students who remember that. But I guess what I'm describing is a manageable set of requests. I found it to be quite manageable. Other ideas or suggestions?
We did a version of the Survivor activity at the latest LIPS conference, which was in Seattle.
Did, by any chance, did Brianna from my planetarium do it?
I guess so, yeah.
Yeah, so she co-developed it with me.
Yeah. Now, that's a very difficult thing. I found it very challenging and difficult. And not the least of which was that there was only, I don't know, 10 or 15 minutes allotted.
Oh.
So that makes it impossible.
It does. Okay. I'm glad you said that, Alan, because I got to go back to all of this student-centered teaching. It really does take significantly longer. But my response to that, and I'm pretty strong about this, is if you can breeze through things with your nice presentation and they're only learning 25%, is that really what you want to do with your time? If it's going to take you twice as long, but they're going to learn twice as much, that's an alternative goal. And it happens to be my goal. You know, I mean, we jokingly say, do you want to cover material or do you want to uncover material? It takes twice as long to uncover material. And so I think what matters to me when I talk to other faculty is I want them to realize how ineffective it is when you rush through. And if they choose to do that, that's, you know, their faculty, they can do whatever they want. But I want them to realize that the real understanding and visualizing really does take a lot of time. And don't forget, we've done it a lot. And the students are doing it for the first time.
I think there might be other examples that are easier that take less time.
Well, if we didn't want to know east-west, north-south is sure a lot easier, right?
Yeah.
So you could cut it down and just say, have I traveled north or south on the earth? How far do you think we've gone?
That would be a way to break it down into parts.
Yeah. I don't think that our students are particularly tremendous here. You know, we're a state university. We've got 25,000 of them. They're not uniformly used to working real seriously and hard. So I have been pleased that given an hour, they can figure out the east-west as well as the north-south. We do keep them in the northern hemisphere. Probably about 20% of them go the wrong way, east or west. But, you know, I think all these things are pretty practical and good for them. I mean, they've heard of time zones, but if you ask them, okay, you're on the phone with a friend in New York, how does the sky differ in New York right now compared to California? How does Washington, D.C. differ from San Francisco? That's a legitimate question, you know, and it's not obvious to them, but given an hour to think about going east, going west, what happens, they come out much more cognizant of stuff like time zones and what they mean. And like I said, about 20% go the wrong way, but 80% go the right way.
So I see in the chat, Josh Roberts said, I really love the Survivor Lab. Can we steal it?
Oh, absolutely. Yeah. Let's see, what's the easiest way? You know, if you don't mind, shoot me an email and I'll just send you the Microsoft Word master. And the reason, oh, actually, I'm sorry. I was thinking of the outdoor Survivor. I'll send you the indoor Survivor. It's kind of fun to do the outdoor thing too, because almost every campus has some nice place or some nice view. Well, I guess maybe not everybody has a nice view somewhere from campus, but a lot of campuses have a nice view of maybe sunset. Anyway, send me an email. I'm happy to share it.
So then,
yes, that's the right email.
So then Vince Tobin is saying, when they ask for when the sun rises or sets, do you give the universal time?
No, that is one step too complicated for them. So we do everything on the time of the university, the time they're used to every day.
I noticed John Erickson is in our session here.
Uh-huh.
And I know he's done a lot of things in his planetarium. And when you have, now we don't have groups of 100, our planetarium holds 50 or so.
Right.
John is at the Lawrence Hall of Science Planetarium.
So when Alan says his planetarium, he means
yours.
He means
ours. Yeah.
his own, our planetarium.
But you've used the technique of breaking up into groups for different activities. Do you have other examples of things?
Oh, absolutely. Absolutely. Without question, okay, I'm going to speak carefully. Most of the teaching of this kind that I've done is with college freshmen or sophomores. and non-science majors, which represents about 96% of our clientele. Okay, we have about 2,500 students take astronomy each year, and 2,300 are non-majors. And that's what I specialize in. So, speaking of that group of students, without question, they perform much better in groups of 3. They're more confident, they look at things differently, and they share ideas with each other. And my absolute favorite thing, which I kind of semi-intentionally invented back at the University of Chicago, but I had no idea how well it would work out, is the very first week of astronomy class, we send everybody out from our science building, which is a nice tower type of building called Gamov Tower. Anyway, we sent them outside with big cardboard triangles that I made up 20 years ago. And one side of the triangle is 2 feet high, and the short side of the triangle is 1 foot. Then the hypotenuse is, I guess, the square root of 5 feet. Oh no, anyway, it's 2 to 1. We give them the triangle and a meter stick, and we tell them, we want you to go outside and measure the height of this building. And we're not going to tell you how to do it. We do, every class I teach, I do that the first week. It blows their minds. I have undergraduate student assistants because we have this wonderful program. You can Google it, called Learning Assistants, developed here 15 years ago. And so they help me hold hands to the students. And at first they say things like, well, this isn't a lab. This isn't I say, why not? And they say, there's no instructions. And then I say to them, and my assistants are coached to say this, well, when Dr. Duncan says that science is really creative, this is what he's talking about. So go be creative. And we do give them a little bit of scaffolding. They have a handout sheet, and it says, sketch the building, sketch a triangle that has ratios of 2 to 1. Can you sketch 2 to 1 triangles of different sizes? So they get to do that and make a little sketch on a piece of paper. Then they're supposed to draw a building, draw themselves outside, and think of a way of measuring the height. And that is just phenomenal because nobody can say, oh, this is complicated. I can't understand how a meter stick works. And on this one, we've had at least 4 different ways of measuring the height of the building. I thought they would use ratios and proportions. We've had one student stand in front of the building with a cardboard triangle, take a picture of it, and figure out that it took, 56 of those to reach the top of the building. We've had various uses other than the ones I imagined they were going to do, but all of this gets them into the mindset of, oh, okay, I'm expected to think up something. It doesn't have to be exactly what someone else is doing, and I can do it. And it's so wonderful because I collect all the data. And this, from the very first time I ever did it, every single year, it turns out the same way. You get a rough bell curve, and you get some outliers. You always get some screw-ups, okay? And it's a wonderful thing to take that data and then talk about, why do scientists repeat experiments? Why is it not a waste of time that 2 different groups measure the expansion of the universe? Or more than 2 groups of scientists do something. Okay, what do we do? Why is the answer not always the same? Oh my goodness, everyone has errors of measurement. We introduce that concept based on their own personal experience, which makes it much more meaningful to them. We say what to do with all the data. Maybe we should average it. Okay, here's the mean, we're going to average. What is a way to describe how much it scatters? Let's invent a standard deviation. We never even talk about a formula for standard deviation. We look at the bell curve and we graphically say, oh, that's a pretty good approximation of how accurate you guys are. You scatter like this, except for those clowns over here who are the outliers. And you're going to think I'm making this up because this couldn't have gone any better. But the very first time I did this, did it at the University of Chicago, and I get a rough bell curve at about 20 meters. And one measurement out here at like 58 or 62. And I'm showing this to the class, and we're talking about the meaning of measurements and errors. And I go, what does this point mean? And some student, I wish I knew who it was, I'd go shake his hand, but I shouts out from the back of the room, means they fucked up. And the whole class at Chicago starts laughing and laughing. And I, of course, I laughed too. And then when the laughter died down, I said, it's funny, but think of the power of this. We don't even know which 3 students those were, but we know they made a mistake because all the rest of you got 20 meters and they got, and before I could finish the sentence, 3 voices in that classroom shout out, meters? Okay, they all got 60, we got 20. Guess what? They turned the meter stick over and they measured in feet. So I couldn't have planned it any better if I'd paid them to screw up that way. So that's my other favorite activity that we've developed that allows for a lot of student creativity. And it naturally allows a rich discussion of measurement error, standard deviations, systematic versus random errors, stuff like that. I wish I had 10 more activities that were imaginative like this. And if some of you invent some, you get to email it back to me. But that's what I got.
Well, let's see if anybody here has anything they want to share.
Yeah.
Well, first I wanted to ask if, can you hear?
Yes, very well.
Have you ever had a student ask for roof access so they could drop the meter stick and time how long it takes?
Not yet.
I read that in a book about a problem like this. And
I bet it's happened. Honestly, because we are CU Boulder, I do put into the instructions that you may not climb the building.
Oh, yeah.
We actually had a student climb, not the science building, but the dorm building next to it, and that scared a lot of people.
Well, back to Alan's question. A very old, 400-year-old activity is looking at Jupiter's moons from night to night.
Yes.
And, you know, in the public shows, you can do it very smooth, but that's a great one to take your advice to heart and say as little as possible about what they're looking at.
Yes.
And to make sure that people who are sitting near each other are observing or paying attention to different moons so that the conversation they have about what theirs have been doing for 9 nights or so is like what the others are doing or different from what the others are doing, rather than just saying, notice how they all do this or that and being smooth. And
you know, thank you for jogging my memory about that. Years ago, I used to do a quantitative activity with the majors, but I think in a planetarium, you could be like Galileo. You could look at the moons from an Earth-centric point of view, and you could look on successive nights and see them change their patterns. And then you could ask the people in the planetarium, what do you think's going on? And then you could take it a step further. And if you've got, you know, a video planetarium, then show them a top view.
Mm-hmm.
So I really like the idea of letting the people do more. Yeah, I'm going to follow your suggestion.
John, do you have any more of those?
Well, I came late to this because I was doing our program Journey by Starlight, where we navigate from Hawaii to Tahiti, and then the audience has to get us back to Hawaii. And
oh, really?
Right in the middle of the show is the turning around point. So we don't formalize groups, but we say talk to whoever's near you, and it's usually a family group. Which way should we point our canoe and why, given the things that we learned on the way down?
You know, John, is a script for that written down anywhere?
A few different versions of it, yeah.
I would love to have a copy of that. It's kind of poignant for me because, as pure coincidence would have it, I was in Tahiti 3 weeks ago, and I'm engaged to a woman from Hawaii. She's not an astronomer, she's another scientist. And out in Hawaii, you know, they've built a replica of the kinds of canoes that were used to settle there. It's called Hokulea.
Right.
And I've seen Hokulea and talked to people who navigate it. And so even though I don't know too much about astronomy history, I have a personal connection to each thing he said. And I would do it in the planetarium with my students. I'd show them a picture of Hokulea, and I'd probably take them halfway and let them go from there. And by the way, the people who did that, you know, we do this in our planetariums and we show them pictures. I'll tell you what, you get on a small boat out there in the Pacific, which I've only done, you know, briefly, I am in awe of the people who successfully, you know, settled Polynesia. I guess, to be fair, we don't know how many people missed, but they were all pretty damn courageous.
Yeah, my one fear in that program is it may seem too easy. Alan, is that a pass volume?
No, we need to make it one.
You could always make it harder. I'll take your basic stuff and think of something to make it harder.
Yeah, the past series has a number of good activities. We should make that into one also.
Yeah.
You know, I don't know if Brian Claus is still here. He had a question that he put in. Brian? Can you unmute? Do you want to ask that question or should I read it?
Hi, can you hear me?
Yes.
Yeah, so I work with high school students, like older ages, like 11th and 12th grade. And I was interested in talking about this survivor activity. Would you do this with them as more, is this like an intro activity for them, or this is something after they've learned a little bit about the stars in the sky?
The latter. I absolutely would do it with a high school group. I think I've actually done it with one high school group and they really enjoyed it. But both my college students and I would hope the high school has had maybe a class worth of introduction about, okay, Polaris, where is it in the sky? You know, basic sky orientation. I don't think I would ever throw any class fresh into the planetarium. I think they do need some prep about the ideas.
Okay, thanks.
Okay, and then Chrysta, you had a question. Do you want to unmute and ask that?
Yeah, I think it was similar to what Brian was saying, that if we split it up like you were mentioning, Alan, if that could be something we could do for younger ages. Can you all hear me?
Yes.
Okay. And I do something similar. I remember now for, I think around middle school ages, when we do a season show, we go through a day of each season and watch the constellations, and we assign each group a constellation to look for. So noticing when they're up at night and when they're not, and then we look at it from the outer point of Earth, and then we just tell them what season do you think we're in right now by seeing where the sun and the Earth are positioned. So I guess I was just curious, you know, what everyone thought about adjusting it for different age groups.
You know, the one comment I would make specifically on your activity is we did something a little bit like that with inner city kids in Chicago when I was there some years ago. And one kid came in to one of the classes and he was all excited and he said, I slipped on the ice, and when I looked up, I saw Orion was like really there in the sky, like just like at the planetarium, and it was just so amazing. And so you know, for us, it's like show them in the planetarium, then of course they're going to look from their backyard. Maybe that isn't 100% a given. Maybe the one thing I would add to the activity is to say, now when you go home, would you show your parents and your siblings your constellation?
Mm-hmm.
It's the only thing. It surprised me, the need to say that in so many words. Might not be a bad idea.
That's a powerful thing, actually, to say, you know, to take something home. I mean, in the Constellations Tonight program, where people learn how to find constellations, they get to take their star map home after they've learned how to use them.
Yeah, that's good.
Yeah.
And we print out little constellation papers and give each group that slip so they can take it home with them.
So show your parents how to do it. That's powerful.
That is good.
Each season it says, was your constellation visible at night or not? And then try to get them to apply that data at the end there.
Yeah, having someone show something to somebody else, that's really the way it sticks in their mind that way. As I was thinking earlier too about different ways that people learn, visual learners and people that have different ways to kind of grasp a concept. And I've always just tried to do it in multiple ways and figure that people are going to tune into the one that works best for them. But then I worry about confusing people because I'm giving them too much.
Hey, thanks, Carl. That we're getting mall noise there.
What
Now.
is it?
Not bad. Not bad.
It's okay. We could hear you good.
Okay, good.
My suspicion is that the risk of confusion from multiple different presentations of the same thing is small. I think it's much more likely that if somebody sees something from 2 or 3 different points of view, that it's going to help them. That's just my intuition, somewhat my experience.
Any other questions or things to share?
Well, the next thing that happens here in Boulder, since it's
pretty
5:30 here, is a trip to Wahoo Fish Taco.
Yeah. We have gone about an hour, and that's usually about how long we go. But you know what I forgot to do when you at midway, when you concluded your presentation, it's tradition for everybody to unmute. This has been a really great session, Doug, and I want to thank you. I think we should give a round of applause for Doug on this. Okay, so unmute.
Way to go, Doug.
Thank you. Well, I feel very fortunate, I was hired at what a lot of people now call the La La Land Planetarium. They used to call it the Rebel Without a Cause Planetarium. And I was hired 1 month before Ed Krupp. However, Ed Krupp had been my TA at a summer science program, and I knew him previously. And he was hired to be a lecturer at Griffith immediately. And I was hired, as I said, take tickets and answer the phone. But I've known Ed since 1968 also. And I had a lot of fun my 4 years in the planetarium. Then I went off to a professional career. I went off to the Hubble Space Telescope. And then little would I have thought I'd end up back at a planetarium, but I'm real glad that I have. I think planetariums are kind of special people, sometimes a little different, but we have a lot of fun.
Okay, well, thanks again, Doug.
Okay, thank you. Probably see you around.
Okay, we'll sign off then.
Bye-bye.
Bye.